Max and Min love to visit their Grandad in his architectural office. Architects design and draw up all kinds of buildings, such as houses, apartments, offices, factories, and even skyscrapers. So their Grandad always had interesting things to show them. During a recent visit, he showed the twins a couple of very unusual buildings that he described as angular. Most buildings, he told them, use right angles everywhere between floors, walls, and ceilings, which make them easier to build and furnish. These buildings use some different and I think more interesting angles. That's why I call them angular. So kids, what do you know about angles? Well, Grandad, answered Min, in video 3.6.8, we learnt that when straight lines meet, they create angles. If the lines are perpendicular to each other, like the sides of a rectangle or square, the angle is a right angle, shown with a little box. The point where the two lines or arms of the angle meet is called the vertex, and the size of the angle measures how far apart the arms have turned from each other, like the hands of an analog clock. And, joined in Max, in video 4.6.9, we learned the names of angles. We have already talked about right angles. Angles that are less than a right angle are called acute angles. If we put two right angles together, we get a straight angle. Angles bigger than a right angle but less than a straight angle are called obtuse angles. If we put four right angles together, we make a full revolution. And finally, angles between a straight line and a revolution are called reflex angles. That's awesome, kids, said their impressed Grandad. You know a lot about angles already. We architects use angles all the time in our work, as do the engineers, builders, surveyors, carpenters, plumbers, and many other people we work with. Have a look at this. Their Grandad pulled out of his drawer a couple of small, clear plastic semicircles. You probably have one of these useful little tools in your geometry set at school. It's called a protractor, and it's used to measure angles. In construction and in many other fields, such as graphic design, product design, scientific research, etc., it is very important that we use angles accurately. When we measure angles, the units we use are called degrees. This is the symbol we use for degrees. There are 90 degrees in a right angle, so therefore there are 2 times 90, that is 180 degrees in a straight angle, and 4 times 90, that is 360 degrees in a revolution. So that means an acute angle is less than 90 degrees, an obtuse angle is greater than 90 degrees and less than 180 degrees, and a reflex angle is greater than 180 degrees and less than 360 degrees. Let me show you with the protractor. Max and Min watched their granddad carefully put the protractor over a right angle, with its middle exactly on the vertex of the angle and the bottom horizontal line exactly on one arm of the right angle. "See here," he said. "Starting from 0, the protractor is telling me that this right angle is 90 degrees, which of course it should be. And you can see here that a straight line is 180 degrees. Let's measure a couple more angles. This is an acute angle, so it must be less than 90 degrees. And this one is an obtuse angle, so it must be between 90 and 180 degrees. Let's use the protractor to check. So the twins watched their granddad place the protractor firstly over the acute angle, again with the middle of the tool exactly over the vertex, and its bottom horizontal line exactly over one arm of the angle, and, starting from 0, they could see that this angle was 50 degrees. He then used the protractor in exactly the same way with the obtuse angle. Starting from 0, that angle was shown to be 110 degrees. The twins could see that the protractor was a very useful tool, but Max had a question. "Grandad, this protractor only goes up to 180 degrees. How do we measure reflex angles which are greater than 180 degrees?" "That's a great question, Max. I can show you a couple of ways to do that. I'll show you on this reflex angle. The first way is to measure the acute or obtuse angle, which always combines with the reflex angle to make the full revolution. That is, this angle here. If we measure this angle with the protractor, we find that it is 60 degrees. So if we subtract this 60 degrees from 360 degrees, which is the full revolution, we will get the size of the reflex angle, which works out to be 300 degrees. Another way to measure the reflex angle is to extend one of the arms of the angle to create a straight angle, that is 180 degrees plus another angle which we can measure with the protractor and add to the 180 degrees. This other angle measures to 120 degrees. So the total reflex angle is 180 plus 120, which equals 300 degrees. So you see, kids, we can use the protractor to measure any angle. The twins were excited to find out that the little plastic semicircle in their geometry sets was such a useful tool. But wait, there's more! As we have just seen, a protractor can be used to measure any sized angle. However, their granddad then showed them that a protractor can also be used to draw any angle. For example, if you want to create a 35-degree angle, all you have to do is draw a straight line, place the middle of the protractor on the end of the line, Then, starting at 0 as always, mark where the 35 degrees is and just join that mark to the end of the line. There's your 35-degree angle. To draw a reflex angle, say 240 degrees, an easy way is to draw the angle which combines with the reflex angle to make 360 degrees. For 240 degrees, the other angle will be 120 degrees, since 360 minus 240 equals 120. If we draw the 120-degree angle using the protractor, just like this, we also get the 240-degree reflex angle. Here's a game you can play by yourself or with friends. Draw or find existing angles and see how close you can get to guessing their size before measuring with a protractor to check. Now you can watch this video again or try the quiz and look at the chart that comes with this video.